All right, welcome everybody. Today is the 21st of June in Dallas, and this is our normal Tuesday night online virtual catch up on robot related things mainly. Tonight we're coming just a couple days after our Saturday contest. So who knows, we might be a little roboted out this week, or maybe not. But we have updates in queue so far. We have Ray, then Doug D, and then I have something, Carl. So Ray, what's going on in your world?
I did some experiments with my air compressor and the little duct taped orange duct taped cans, just to see if it had enough power to shoot at least 10 feet. And it's got more than enough power. I only had like 70 psi on the output. So I think I'm gonna try to find a small tank with a Schrader valve on it, so I can fill it up with another compressor, and that'll be on the robot platform. And I'll just do like a, I don't know. It seems like less than a second of a burst if I just hit the nozzle button, shoots the can at least 15 feet. So that I know like some of the paint gun guys have used. It's like a pretty good size sausage shaped CO2 canister, but I don't know how expensive all that stuff is. But so I was kind of excited about that because it's like, and I'm always coming, if it's a 6-can or can contest, Scott's platforms have a lot more work in them, and I don't think I'm ever going to beat him. It's like, okay, I could maybe try to do what he did, but there's kind of a limitation there. So if I I don't know if he's joining tonight or anybody's going to tell him, but I developed this thing and then just show up with it and give him back his famous line, "I'm going to kick your ass," So but I was impressed. And it should take much less time, because you don't have to pick up a can, bring it to the goal, come back, find it. Well, you still have to find the next one, but finding the next one is just going from can to can to can, not can to goal to can, and and so on. So, but Kareem, did you guys do any experiments with compressed air and shooting cans?
No, we generally stayed away from pneumatics.
Oh, you did? Yeah.
Yeah. We did. I will say that we've experimented with blowing air. Yes. So
Mm-hmm.
we've used a 12-volt bilge pump. It's like a 3-inch diameter bilge pump for boats. And we've built a little cardboard cannon to eject certain things, and it will actually send the little can flying. But we had better luck with actually a what do you call it, catapult style
Oh, yeah.
can launcher.
Hmm. Yeah, I'm thinking the pneumatic setup's going to be pretty compact, and the tank doesn't have to be very big. It just has to hold enough air to shoot 6 cans, and I can refill it, I hope, pretty quickly.
Yeah, compressed air is. It can store an awful lot of energy.
Yeah.
You might be with the paintball things. The sausage shaped things are actually the containers that hold the paintballs. The actual pneumatic cylinders are typically
You're fading out there, Kareem.
I was just saying that the paintball, the sausage shaped components on paintball guns are reservoirs for paintballs, not the pneumatic.
Oh, I thought it looked like a black CO2 tank or something. Canister.
The CO2 canisters are usually pill shaped or oval lozenge shaped.
Oh, okay. All right.
But we haven't really used those on robots. Although, that would be an obvious choice for a limited amount of compressed air.
For what?
for a limited amount of compressed air.
Oh yeah, yeah, yeah. It's actually CO2 though, isn't it?
It is. Yep.
Yeah. Anyway, so other than that, been doing machining.
Ray, can I ask, how were you thinking? I mean, it sounds like you're looking at this as a way to get the cans to the goal quickly and save time.
Mm-hmm.
Well, so doesn't that introduce the new challenge of now you've got to aim so that the can doesn't bounce off the floor, doesn't bounce off the bar, goes underneath, not over, and doesn't hit the wall? Aren't you introducing like a zillion new problems with this approach?
That's
peasy.
entirely possible, but it seemed like just, I have like I don't know, it's like a automotive, I don't know what you call the thing. It's just like an air valve, and you can stick like copper tubing on the end of it so you can reach into places that you couldn't reach into normally. And I was just basically, it's like 3 foot long. So I was holding both ends of it and hit the little trigger button. It's just on off. There's no, variable flow or anything. And if I aimed the nozzle at the top of the can, it seemed like it would tumble, and it seemed pretty consistent as far as, just holding up a nozzle to it and giving it bursts of air as to where it went. So yeah, I could hit the walls, could hit the goal post. I mean, but it stayed, with the rotation, it stayed pretty much just a couple inches off the ground. So I think I think the height of the goal is a foot, and I may have to reduce it down because of too much energy or too much lift on the can. But I think that's the only way I'm going to beat Scott with his his robots. So
the other thing that came to mind as you're talking is that you remember those kinds of fun physics displays where you have the stream of air going up and you just put the ping pong ball in it and it centers itself in the stream of air.
Oh yeah.
So maybe that kind of trick can help you with.
Now, who just introduced a whole plethora of problems with that? I love the idea, though.
We tried that with a soda can, and it did not work like it does with a ping pong ball.
Not the same, is it? Yeah.
No, too turbulent.
Yeah. Not a uniform spherical.
Yeah.
Yeah.
Yeah, I might have to, I don't know, make like an air guard on the end of it, because I still have to get the can in position, and then I could just, pop it with a burst of air, and maybe with a little plastic air director, it'll be a little bit more consistent. But
I don't think there's anything in the rules that prevents you from encapsulating the can in a sabot that's designed to act like one of those round ping pong balls, and then shoot the whole contraption through the goal.
Love it.
You got to be creative in your thinking here. Yeah,
this is awesome.
Actually,
Go for it, Ray. We're right behind you every step of the way.
what you could do is encapsulate it into a round ball and roll it to the thing.
oh
Like
god,
a bowling ball.
Yeah, then you need like a pool cue to shoot
yes.
it.
Oh yeah.
tap
You
it.
can
Yeah.
bounce it off the
Yeah.
walls, and
I think I like my burst of air method.
It's like a virtual pool cue with just air.
Mm-hmm.
yeah,
Kind of
there
like
you go, virtual.
Monty Python. I fart in your general direction. This is kind of like blasting it out.
Uh-huh. Well, that'll go well with Scott's belch robot for the summer, right? So outdoor or burp or whatever he's calling it. No, his first one is burp. His second one is belch.
Yep.
Yeah.
One
Yeah.
thing you might consider, Ray, just for safety reasons. You remember when David went and did the leaf blower?
Mm-hmm.
He had something like a hockey net. He probably still has it. I mean, I don't know.
Oh.
You might just be able to ask him and say, "Hey, can you bring that to the next competition?" Because
What did he do? Set it up behind the goal?
Yeah, we just from because we were at Perot, And
Oh.
you couldn't have can going, pachoon. So he put, it was kind of like a big like a hockey net. And he set it back about a foot from where it was. And it just would have taken care of any situation where the can got away from him. It didn't, but I'm just saying it was kind of a cool precaution.
We could do that with just a piece of paper, basically a waiver saying that, you're not going to hold the DPRG responsible in case you're hit with a can in the head or, something. So.
Yeah, I hear you. I'm just saying is you might consider it. It's not I don't think it'd be a big deal to make.
And you don't have to get a net signed by everyone in the room.
What's that?
You don't have to get a net signed by everyone in the room.
Oh, no?
That would be a good challenge by
Like
itself.
you do the paper.
Yeah. Yeah, if you want to stand here, sign this waiver.
That's right. Stand here at your own risk.
Now, if you could get the can blasted,
No.
yeah.
You just do like you do at the fun parks. Like SeaWorld, they have these seats marked splash zones, and it's a can zone. So you're in here.
Flying can zones. Yeah,
All right.
imagine they could do a little bit of damage. So, bruised egos and whatever else.
Okay.
Anyway, I've been doing some machining, but I still have two different motors that I wanted to experiment with the differential drive platform, and I was making basically wheel hubs for those because so it's basically an adapter between a 10 millimeter shaft and a 3/4 inch hole in the wheel. And I was trying to figure out, I think I'm going to do 4 set screws on each end, or 2 on each end. And hopefully that's going to have enough grip. If it doesn't, I think I'm just going to weld, it's steel, so I can just weld the hub to the axle of the motor, and if I need to take it off, I can just grind it off maybe.
That seems so easy.
Welding is the simplest solution, just and there you go.
Don't you have a milling machine?
Yeah, I have an old Bridgeport.
You can't cut a keyway in that shaft?
I could, but yeah, it's 10 millimeter shaft. That's a pretty small end mill. I'd really like one that's instead of like one that's an 1/8 of an inch shaft, one that's actually like a cutting wheel with teeth, so you can actually cut the kerf with.
They call that a woodruff.
Or a woodruff, yeah. You could do a woodruff too. Yeah, it's pretty thin. It's only 10 millimeters in diameter. I don't know. You might be able to put an 1/8 inch key on it, but it's getting pretty small. And I don't know if there's a standard for, there probably is a certain size key for a certain size metric shaft. I know for inch stuff, I think, I want to say it's 1/8 inch up to half, and then it goes to 3/16, and 1 inch is like a 1/4 inch.
3/32 keys.
Oh, they do have 3/32. Wow, that's pretty small.
Pretty small.
Yep. Yeah, I could do that. I did that on the 4-wheel drive platform. Everything's keyed shafts, which is nice because there is no slippage. But it's so much quicker just to get out the welder and go boom.
Yeah.
And it's
Put a
stuck.
little tack on there.
What's that?
Put a little tack weld on, little tack weld on.
Yeah, and I'm hoping, I don't know if it may just bind on it so well that I can't grind it off or something, but the only time I need to take it off is if their tire cracked or something and needed to replace it because it's the hub's on the outside of the tire, and I'd have to grind it off to pull it off and replace the tire or something. But maybe I'll just be nice to the tires and baby them and never have to replace one or something. So anyway, so that's all I'm working on.
Cool. Very good. All right. I think next in line, Doug D, we had you, and then I have a couple things.
Okay, so I've been putzing around with my telepresence robot, and I made a few improvements and advances, but mostly it's been thinking, but I can show a little bit. Let me see if I get my presentation to work. This is the screen for the telepresence robot, and right here I've added the veer left and veer right on the steering. Before I always had just go straight forward, backward, stop to make a left turn, stop to make a right, which pretty awkward driving really, and now that I've had a little more experience with robots. So if you get it going forward, you can kind of veer it off to the left a little bit, veer it to the right a little bit, then straighten it back out and continue on again. So that's good. I had my method stuff up here I'm probably going to deprecate. From my original method of driving my robot, which is 4 wheels, but you only drive 2 of them, was to drive steps. So you'd move a little bit, wait for the next command, move a little bit, wait for the next command. And then everybody else was doing continuous. So I switched to, I'll probably just do continuous and get rid of this other stuff. So, and I got my speed stuff working now. So that was good. And I'm not going to show it actually running this time because it doesn't do anything more than what it used to do. And I think I stopped sharing. And so that was that. I've taken Robbie apart here if my robot killing dog doesn't jump it. And I got his body off here, and this is where I'm going to put my battery connector for a Ryoko battery, like a tool battery. That'll go right in there. Then I can just stick that battery in there. That's an 18-volt battery. So I used up my 18 to 9-volt step down the voltage regulator. I'm gonna have to get another one before I can actually wire that together. And that'll be good. This is the Roby's front here. And right in here, I'm gonna put some wooden things that I've got so that if it fits, if it goes in there, then I can slide or hook the computer parts, which would be the Pi and the Arduino on there. And then I can have easy access. I don't have to take the body apart to get to them. Because sooner or later, I'm going to have to update the program or do something like that. So doing thinking stuff like that, but I haven't actually mechanically attached it yet. It's all thinking so far. That's all I had. Just a little update bit.
So Doug, after watching the contest virtually on Saturday, I realized that it would be really nice to have a pan and tilt on a camera.
Right.
I don't, driving would be great, but just having a camera that I could pan and tilt without asking Carl to do it would be wonderful.
Yeah.
Yeah, is that an English forward? I don't think forward has an E in it, does it?
My math or my spelling skills aren't as great as they could be. It probably is old English. It's an old robot. So I have this selfie stick, which calls for a servo to pan and tilt the telepresence part, but that's going to be the Skype part. The robot itself, you control the robot killer here. He's down there trying to kill my robot pieces. The actual camera on the robot, I intend to have a pan and tilt, but I don't know if I'll ever get it. Let me go back to presenting just real quick here. This part right here was the camera left and right. Oh, right down here. Camera tilt up, down, left, and right. And that was meant to be this driving camera over here, which is just a little, could be a Pi camera. It could be, right now I have a webcam attached in there. Pi can take either one. So I'm intending to do camera pan and tilt. I hadn't decided if it was going to be on the telepresence part, which was my plan, or actually do it on the driving part.
Yeah, well, pan is pretty much the same as turning the robot left and right. So
Right.
you've got that.
I could save a servo by doing that, but
Yeah,
it's a noisy little robot if you've ever heard it run.
right.
All the more reason to put it in the DPRG space, because my attack dog hates it to no end. And anytime it's on the floor, he gets feisty. If it moves, he attacks. He's a robot killer. So I can't use it for roaming around my house like I intended on.
So those high frequency grindy gears, right?
You know, I don't know if it's the gears. It's got some really noisy plastic gears, but it's got a number of those ultrasound things, which I think he can hear.
Oh, yeah.
And he may be able to see the lasers. Who knows? He just hates it now.
Yeah, we have some dogs that when we pull up to our gate, that next door neighbors' dogs, they'll like run up alongside the car and bark at us. And my wife found an app that it's like a kind of a high pitched, increasing, decreasing tone, and they're like mesmerized by it. She just hangs her cell phone out the window and they shut up.
Yeah, I actually put a little piezo unit on my robot once, and I made it make a really pumpy sound, and that scared him off. But he's gotten used to the fact that it didn't chase him after it scared him off, so now he's braver.
It's like, ruff. Yep.
So I yield my time to the next person.
Okay, cool. All right. Well, I have two things. The first is a little contest day follow-up, and then I have a robot thing. So on contest day follow-up, by any chance, John, are you there at the space, or is anybody there at the space now?
John, I don't think is at the space. Are you at the
Actually, I am
makerspace?
yes, in the small room.
Ah,
Okay. Because as
See
it
the
turns out,
background?
we had no
Yes.
sooner left. And do you remember when we were leaving that there was a hat over on the side of the
Right.
wall? And then
Right.
there was a laptop power supply by the front door.
Well, it was down below the chair, but yes.
Harold, did you get your hat by any chance?
No, I haven't gotten my hat yet. I hadn't had time to go by the
Let me
place.
go see if it's there. See it?
Yeah, so we've discovered the hat belongs to Harold, and
Okay.
then the power supply we think belongs to Jack. Not that kid that, not
Oh,
Dilbert's son, but
right.
Jack.
I'll go check.
Okay. Yeah, if you get a chance, I would appreciate that. I'm sure
I'll
they
do it
appreciate it.
right now, in fact, because
oh, that
yeah,
belonged to 7 Photons, Jack?
7 photons, Jack. Yeah.
Yeah.
And he's in a class or something right now, so he's not able to join. But well, thank you, John. So okay, so my update from Saturday relates to some insight that I had, and for that, I'm going to share my screen. Hopefully, this doesn't distract John too much. Let's see. Okay, so it's presenting. All right. So if you remember when I drove this, I did the 4 corners with HoverSim 2 different ways. This way was just the driving straight mode, and it actually did all right. It just driving straight. Let's say on the order of 40 feet of travel, it got within 4 inches. So that's within about 1%, right? Pretty good. And it had nice, clean right corners, and it drove at right angles to itself. So so I thought, okay, well, this is a good sign. That means the IMU is holding because it's totally dependent on the IMU for knowing which way to steer. And then it just turns the wheels at a certain velocity, at a certain constant velocity. So if the IMU gives it bad heading data, then it's screwed. And I had noticed before the contest started, I had this sensor in 9 degree of freedom mode. So it was using gyroscope, accelerometer, and magnetometer. And that had actually been doing okay with the smaller four corners, but when on contest day we bumped it up to this larger square, I think the thing got closer to the walls or the chairs or the people or different place in the room, and all of a sudden you could see the gyroscope would go out of cal and then it would go haywire crooked. So, that day on contest day, I turned off the magnetometer and I just put it in fuse, accelerometer, and gyroscope mode. And that's how, like on this run, it managed to do so good. And I thought, okay, then it should be doing pretty good in the spin mode too. So then came this next thing that I noticed, and I don't have very good videos here, but 56, that's too far. So this is the corner right there. So so in spin mode here, so it's kind of hard to tell from the angle, but it's driving in a pretty straight line here to the first corner. And then it takes the first corner and it does a pretty good right angle as far as I can tell. So it goes about there, and then it does a nice right angle and pretty square, I think, pretty close to 90. And but then it gets to this second right-hand turn by the farthest cone. And this is I don't know which run this was, first or second, but it had the same problem on both runs where it got to this point of the floor and it made what should be a right-hand turn, but if you watch it, you'll see that it's much sharper than a right-hand turn. That's not 90 degrees, that might be 70 degrees or something. See that? So it totally lost it on that corner. So I was thinking, well, the drive straight mode did that corner just fine. So maybe that corner, because it's so not flat, maybe that's what's going on. Well, then on the third run, I thought, okay, well, if it's that corner, then let's just see. I should be able to try a different place. And I should, maybe I can get past it. So let's go to 119.36. So I started about.
Where is this video lagging for everybody else?
It'll be lagging.
Video's
Mine's not moving at all.
Oh, so I can't, I'm sorry. All right. Well, anyhow, so that is just too much of a screen scrape then. Yeah, it just can't. It's on a 4K monitor, so it can't keep up. All right. Anyhow, so the trouble. So okay. Anyhow, what I found, or what I'm suspecting, is that like when I started at this other location, in the room. Let's go back there. 120. Yeah, so I started, this is the corner where it screwed up, right up here where they're in front of John. And so I started here instead of the one down to the left. And so it went around, and this time it screwed up on this corner, which the last time it took nice and square, but this time it made the same too sharp turn. So I'm thinking, okay, this can't be the floor, because it took that turn sharp when I started here, but it got screwed up when it came here. And then anyhow, with the driving straight, it took all four of them nice and square. So what I'm thinking now is that when you put that IMU in that constant spinning mode, I think it's screwing up the fusion algorithm in the IMU. So I have a theory that I'm going to test at some point, but because why else would the IMU held fine when it was driving straight, every four corner nice and square, but when you're spinning it, so I think I basically made the robot dizzy. So basically what I'm going to try when I get a chance here is to go I'll go halfway, I'll stop, and I'll spin the other direction. Go the rest of the halfway, I'll stop. I'll spin the other way, go halfway, stop. I'll go halfway, stop, and the other way. So I'll see if it's winding up, and if I can wind it and unwind it, and if I can take care of that losing orientation problem.
Yeah, I was surprised you were doing really snappy turns because I thought there was like a maximum rate for all three. You know, the magnetometer, the compass, the gyro, or well, that is the compass. Anyway, gyro, accelerometer, magnetometer.
Well,
I thought they all had like maximum rates that you could, or that it could keep up with.
It's 50 hertz.
Oh, is it 50?
well,
Yeah,
I mean,
I
there's
believe.
there's the sample rate, and then there's the rate of acceleration. And I would say that, I mean, I'm only sampling at 20 hertz, not 50. And for as fast and as snappy as it seemed to turn, I think it's really a fraction of the dynamic range of the
The
gyro
full scale. Yeah.
accelerometer. So, and the other thing is that what you're seeing and how snappy it is. Well, that's just because I took pains to make the heading loop be as responsive as possible. So it's like
Mhm.
pretty as close to critically damped as I could get it. Which is fine for snappy turns, but on that slippery floor, it probably hurts my offsets, right? It probably slides around and screws up location. So
Yep.
that's the other thing I was thinking of. In addition to changing the spin mode, so it changes direction every now and then, maybe it keeps itself from getting dizzy. I was going to put a low pass filter between the command for these self-driving modes, between the command and the PID loop set point, so that like David uses a slew rate limiter, I was just going to put a low pass filter in, so that it slowly ramps the speed up to the set point, and hopefully in a more gradual way, and avoids sliding around on the dusty floor. And also, like, those wheels are not equal, so you can tell even when you give them all the same speed command, one of them or two of them will kick in before the others. So like when you first started to move forward, it should just all four forward, same direction. It actually jiggles a little bit to the side, and that's because like a couple of wheels start up before the others. So I figure a low pass filter, I mean, poor man's way of give everything time to catch up.
So, Carl, I was kind of surprised that spinning around, it seemed to go in a fairly straight line. Just the turns weren't 90 degrees,
Right.
which I thought was interesting.
Yeah. And but I think that's a part. I think that, well, we'll see what my experiment has to say, because
Yeah.
I mean, it's the same IMU, right? And the only difference between those runs is that one was going straight and it only turned three times for the turns, and the other one, it was turning how many times? So it's
Right.
so
Was your navigation based on distance and then the gyros?
well, I put it this way: is gyroscope for head, or IMU for heading. So it was a 6th accelerometer and gyro. So it's IMU for heading estimate. And then instead of distance directly, I measured wheel velocity and time.
Oh, okay.
So it's not measuring distance directly, but it affects its distance.
Yeah. So if it went further than well, that doesn't make sense. I was going to say if it thought it went too far, maybe it was trying to head back by taking a tighter angle or something.
No, it's just straight time and speed. So so I think the only the one explanation is the floor, but by starting it at a different point and then seeing it screw up in a place it didn't screw up previously, maybe the floor drops out, and I'm thinking it could be the IMU.
Right.
And plus, that's something I changed on competition day, because for the last year, I've been running in a 9-DOF mode where it fuses gyro, accelerometer, and magnetometer, and that works fine in my garage and around the house here. And it was working all
it
right.
worked at home.
It was, yeah, it worked on my machine, but it
Yeah.
it also worked reasonably well in that very same space when the orange cones were closer together at the makerspace. But when the cones were further apart, it's a different path.
And before you started, you spun it around to calibrate the magnetometers?
Well, I store I basically calibrate the BNO 055 for that thing, and then I store it in EEPROM. So every time it
Oh,
boots up, it has an initial value, and then I think it's just the background task inside of it that tries to keep it calibrated.
Mm-hmm.
But I have a light that shows when it goes in and out of calibration, and it was night and day. When the magnetometer was being fused in, it would drive a few feet. It'd get close to the one wall where people were sitting, and it would just, the calibration light would go red, so it's out of cal, and then it'd start driving like 30 degrees the wrong way.
Yeah.
And then a little bit later, the light would turn green, and then it would, like, it would average out magically somehow. But I got rid of the magnetometer and just let it fuse the other two, and it was really consistent until I spin it around constantly. And that's the other thing. I couldn't find
Remember
it.
the fudge factor discussion? Like
Say what?
you and David were saying, you have to, like, to get it to go, say, in the direction you want it to versus slightly off one direction or the other, you had to add a fudge factor. Do you do like 4 individual segments, and then do all 4 segments have the same fudge factor?
All right. So, okay. So, so the way it's now, it's hard coded. So it's always in the spin mode. It's always turning in the same direction. Okay.
Okay.
And I have empirically, by putting it in spin mode and commanding it to drive forward. I mean, it's a really stupid, simple thing I did in my garage, right? Spin mode, I'd command it to go forward 8 feet. And instead of going straight, it would be off by 30 degrees. So I'd measure the distance and say, oh, that's about 30 degrees. Or I just like, and I said, okay, so instead of asking it to drive straight, I'll ask it to drive 30 degrees in the other direction. And then by the time I put that in there, and then I say drive straight, but it's just hard. It's adding this hard-coded offset of 30-degree vector, and then it drives straight. So what's going on there, and I had figured this out long ago when I put that fudge factor in the first place, is that you got a few things, right? So the IMU, there's going to be some delay inside of the IMU from the point at which it's at a physical location to the point that it knows it's at that physical location. So it's going to be some kind of lag, right? And then there's another lag that's going to be a random variable due to the 20 millisecond sample period. So, it's at 20 milliseconds. When the thing is spinning around as fast as I'm spinning it, maybe if it's truly heading here when it's sampled, and the IMU knows it about here, maybe the Arduino Mega in my code doesn't know it till here sometimes or there sometimes, right? So that's going to vary based on, and if I spin it faster, then because it's like a fixed delay for the communication, if I spin it faster, it might not know that location till it's way over on this side. So that fudge factor, I think, is going to need to be a function of how fast it's spinning, and then it's going to be a random variable because of the asynchronous sample rate of the 20 millisecond period to the IMU period. So there's what's going on, and so right now it's hard coded. So I was thinking it would be easy to just change direction, but now that you mention it, not only would I have to change direction, but I have to add other code to swing it so that the compensation is matching the direction of spin, right?
Yep.
So I'm just doing it simple, hard coded for now, and then maybe eventually I'll get it to where it rotates as a function of how fast it's spinning. But that's only good if it's spinning at a constant rate. Because if you're changing the rate of spin, speeding up and slowing down, then oh guys, I'm not going there. It's just too much math.
Well, wouldn't you be anyway? Because that slickness on the floor, which we all know it is, means that you're really not spinning at the most constant rate that you're thinking at. Maybe it's close enough.
Well,
maybe.
Yeah. So, in my robots and in life in general, I rely on the central limit theorem a lot. Central limit theorem says that all these random processes at the end, they tend towards a bell curve. So
definitely a
somebody out
rabbit
there
hole.
with a PhD can go model all these different effects, but I'm just going to say, screw it. It's a bell curve at the end of the day. They all add up. We'll just tune the knob until it's about right. That's my technical theory. I'm sticking with it.
Turn the knob till it's about right.
Yeah, close enough. So there's actually a story. My controls professor at CMU he was explaining on the same day that he was forcing us to go to page 339 to look up Lyapunov functions. He was explaining that after all that, explaining us all these higher order math control loop theories, he said, at the end of the day, the Russians and the Americans, when they had the space race and they were steering the capsule around in space, the lunar lander for Apollo was a second order control loop, right? None of these fancy Lyapunov functions. There's just a simple second order control loop. And he said the Russians had an even simpler process because they didn't have that fancy computer on board. They did they looked through the window and they said that's where I want to be. And they got a grease pencil. They carried a grease pencil and they marked the window on their spacecraft, and then they just goosed the controls until they kept the optical mark of the grease pencil in their window looking in the right direction.
Yep. Yeah. To
And I
your
thought,
left. No. To your right. To your
study
right.
these crazy functions for control theory. That's just not right.
That's the level I think on.
Yeah,
Just goose
That's
it.
it.
There you go.
it works. Okay, but this is not the time to give credit to Russians. So moving on. Although probably some things have never changed, right? From the grease pencil approach, just so crude.
I actually heard that pilots can use that to avoid collisions. Like if you think you're going to collide with another plane, you basically you have to keep your head in the same position, but you make a mark on a window, and if it doesn't change, you're going to collide. So I always thought that was kind of interesting. Oh, okay, that's how you do that. So maybe the Russians did have something there.
Something simple. Well, there's something like about Hubble. The early days, they were saying that all the years of delay and the really expensive repair for Hubble. So once they figured out what it was, they figured out there's all these write-ups saying that if someone had just gotten a candle and a 3x5 OTAG card, they could have shown that it was a problem on the ground before they launched it. A candle and an OTAG card, they would have found it immediately. But they were relying on all these super fancy unit test level measurement things. So it was escaping defect. Okay.
Well, hopefully somebody remembered the grease pencil in the for the cosmonauts. Oh, you have grease pencil? No, you? Oh no grease pencil.
Pick the finger, there's the blood.
Yeah, there you go.
Okay, I'm going to stop capitalizing things then. So let me just ask though. So John, did any luck by any chance with Lost and Found or The Room?
So what I found was
Your video needs broke up, John.
It's like the deadliest catch when they're pulling the thing out of the water to see if they got any crab in the crab pot, and then
And then the screen freezes.
He's frozen.
Cliffhanger.
Oh man, John, we're on the edge of our seat.
Isn't that a commercial for fiber optics right there?
Commercial time, right?
Where's our quantum entanglement communication path? Oh wow. Why is my screen frozen?
There you go, John.
okay. Hey,
We didn't see anything you did. You froze for a long
I
time.
know. That's why I'm like, as it said, lost connection. As I was demonstrating when that got moved from the table because the people that do woodworking, he was in the room, and so he had moved table. But luckily, he put it on a chair, instead of taking it to the lost and found area. So you're in luck on that. And then the other thing, the thing for Jack is
Wow.
this. Okay.
Go.
So you can ask Jack exactly, but it sounds like you think it's Jack.
If
So
you can
it
hold it up, I'll
says-
get a screenshot and mail it to him. So
Okay.
pull back just a little bit. Was it still plugged into the same place?
It was plugged in the same place. It didn't move.
Oh, wow.
Luckily. The hat
So the
did
odds are
move.
high.
So
Okay,
the
and
hat
then
would
if
have
you
been
could-
more of, yeah.
If you can hold up a photo of the connector at the end of it.
Okay.
Probably just a barrel jack, right?
Yeah.
Yeah. Well,
It does
versus
have
the USB
blue.
style.
So you can ask if it
Oh,
has
yeah.
a blue tip.
Yeah, I'll ask him. John, you are a miracle man. Thank you.
So then the matter of, when, how, but I guess we'll figure that out. I don't know if, in the case of the hat, I'll be here Friday even. I can tell you that. I'm doing blacksmith on Friday. I don't know if you want to come by on Friday, Harold, or
Sure.
whenever.
About what time Friday?
Probably after 5
Okay. I can roll in there
Or
5:30, 5:30, 6
or
o'clock. So
5. I mean, I'll be here all even, Friday even. So
Okay.
it's really up to you. When do you want to be here most?
I've got a Twitch stream that goes down at 8 o'clock. So somewhere between 5 and 7 o'clock, I should be there.
Okay, I'll be probably in the back.
Okay.
On the back left side corner of the building.
Okay.
And I'll tell Jack about this power supply, and you guys can sort it out somehow. But
Right. Well, in his case, A, if he wants to come here on Friday, or B, I guess we can work it for him. I don't tend to get up north that much. So.
yeah, you can.
Well,
Well, if
what
you'll
I
get
might
it on
do is
Friday
drop.
evening,
What I might do is drop it off at your house, and then he can come to your house. Thought type thing.
halfway in between, that's okay.
Yeah.
But if you can hold on to it, that's awesome. At least we know where it is.
I'll hold on to it. So with that, I have something to show video. So I don't know, but it's like interesting thought for the next contest. So let me click on something. Yes. So there's
Snake robot.
this. We don't need music. Unless y'all want lively music, but
It's all right.
those are, yes, let's neat for a couple reasons. See, they can do a left turn. And to me, it looks like the floor is not all that level. So, Carl, I think it might solve that problem.
Yeah, now there's a robot that we need to do for
And then it does, that.
That's
And
pretty
that's the
cool
part
there.
that really got me more interested.
Yeah.
See, that way you could dial
Cool.
into the spot.
Hey, there you go. It's got a swerve wheel.
So, yes. So I thought that was neat.
Cool.
So yes, it's a thought.
That must be, promoted by a company that makes servos or something. You probably need 16 servos for the thing.
Probably at least is my thoughts based on that. But I did like the fact that it was able to turn. Very
How does it
precision.
move? What's on the bottom that grips the floor?
I'll
How's it doing
remove
its
it.
move? It's not wheels or nothing. It's just
Let me get back. Okay. So Yeah, it looks like it has lots of little reels there.
Hmm.
Okay. You know, each of those little spots looks like real miniature reels. So think roller skate.
Not seeing close up of it. It
Well,
looks
I'm
like
hoping it's get
it looks like they might have motors. And
oh, it's a
driving
bunch
the
of
wheels.
servos. Let's see, probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of them. Let's see, snake robot. Okay, I don't know if. Let's see if that gets more details info. Okay, so yeah, you're seeing that. Okay, here's more detail of it. Oh, okay, so yeah, it's lots of little reels with the camera or something on the top. Oh, and then the control boards in the back. Okay, trail segments, 7.4 volts. Uses a mega, so it has memory. Okay. Lego reels. Yeah, it's pretty straight overall design. I don't. Oh, that's a controller for that. Okay.
Receiver.
Okay. Here's math for the people who like math. Okay. Well, actually, it looks like he's did a very good job of defining this robot. Okay. Let's see how.
That's it, pretty much.
Well, that doesn't show wheels though. So
On this part, no. Like, remember at the tail end, you basically have it on its side.
That's more of an inchworm there.
Yeah, for me, I was thinking more inchworm, but here was where he had the reel, I think, going. Okay,
To me, it looked like pinching the inch on the side instead of on the wheeled side.
Okay. That one up, going. Okay, so I guess go to the top to play. Huh. Okay. Oh yeah, but there's where the reels went, where he did that snake light. So actually, that's well documented.
Manufacturing automation was simple.
Ah, there's movement. And the floor definitely does not look very level there, with the real gaps on that. So
I wonder if like one segment has continuous rotation servos and the wheels are just passive, maybe.
I think so.
I think
Let's
they
see.
are.
What
No,
did it
look at it.
say?
I think
Yeah.
it's depending on the wiggling,
Servos.
basically.
Yeah. It just says servos. Yeah, just
And
plain
one
old
continuous rotation servo down lower.
Yeah, down below. Right underneath the 12 Lego wheels.
But that's probably used for when he wants to pivot
Yeah.
with the head.
Yeah, because, well, it has to be almost at the head here, the sensor for the head. So yes, I thought that was cute, and he actually has a lot more documentation than I thought. It was one of these, collection of 10 different things type things. So that's
cool.
what I found today.
Very
Call
nice.
that fun with servos.
Nice, yeah.
Cool. All right. Thank you, sir. All right. So those are the ones we knew about before. What other topics or questions for tonight?
I've got a couple things.
All right.
I will guarantee you no one has one of these. This was a Paul Daddy Day gift for Father's Day from the wife. It showed up today.
Would you look at that?
Transparent LCD.
Yeah, that's what we got going on there. That's one of my sayings. You are who you want to be. I'm sorry, I'm going to be a jerk. No, I don't think you're sorry because that's who you want to be at the moment. There you go. And the other thing was, I'm going to put a link in the channel. I just looked it up again. It's Adafruit's been doing these chip shortage things where they get up and they're using the power of who do you know, so to speak, and maybe they'll get some stuff done. The latest thing is the AT Mega 328 chip that we all know and love and use in all kinds of different ways. Well, Adafruit's been waiting on their order for over a year now, and Microchip just pushed them back another year.
Whoa.
So what that means is things like the feathers, the huzzahs, and some of those other sort of stuff that they do, they're going to not be able to make them in just a short while.
Wow.
Yeah. And
What's going on with all that?
it's a chip shortage. Like right now, go try to find a B&O 055. Just try to find one. In any way, shape, or form. Really hard to get because there are a lot of things they're in short supply. You can blame it on lots of stuff. But basically, when you shut down these chip fabs, you don't get to turn them back on like that, and then everybody's get their order piled up, and whoever's got I don't know what the pecking order is.
Money.
It is, but let's just say hobbyists with Raspberry Pis and stuff like that are probably on the lower order of that, especially when you have an automobile sitting idle because you can't make chips so they can put them in their computers and they can be sold.
So do you think they're going to have cars back up and running again then, based on that thought?
Maybe they're all saying they think about this time next year they'll be out of it. But as long as things, like we don't get flying dung beetles of death with 3-inch stingers or something in there, it'll be all. They're looking at coming up back then. Mauser does have pies on order, Raspberry Pis on order. They say their shipment's supposed to arrive May 12th of 2023.
Wow.
And what's happened is Upton was on there, one of the blogs or something on the Raspberry Pi folks. You can get a Pi 400 pretty easy. A lot easier than other things because people don't want the keyboard version of the thing. They want the small card. And They say they can manufacture about 500,000 a month, and there's a priority. The commercial vendors get them first, and then it goes down the way. But they say they need to be producing somewhere over 1 million units to satisfy everybody on a monthly basis, and it just doesn't exist. It just doesn't exist. You know, I'm sure there's other more things like that, but there you go. Oh, and another epiphany after the end of the thing, I could have put my Zemo here into the contest using the old brains and literally a for loop and about 3 or 4 commands to compete in the Foursquare. And because because Franklin did a really good job of timing alone. And I'm thinking with the 6 wheels that I have and the fact that the unlevelness of the floor probably would not have bothered this rover in general, because there's be all time one of these wheels would probably be touching to get me going forward and that kind of stuff. And literally a four loop with some timing, spin mode, turn right for X amount of time, go, and repeat 4 times. Probably could have put this in the contest, and I just didn't realize it until way after the fact.
So you could have given the 11-year-old a run for his money.
I could have, yeah, exactly. I could have. It's awesome.
The trick is getting those timing robots to go straight for that whole time. Mine tends to veer. I think Ted was talking about it last week. And it veers like 2 degrees one run, and then the next run it'll veer 5 degrees. The next run it'll veer 3 degrees. It's like consistent.
Well, I'm gonna use this. I'm gonna use Carl's theorem of normalcy of all things.
There you go.
I have 6 servos that have are speed controlled in and of themselves. So I'm betting over the averaging of all those 6 servos, I think the timing probably would be pretty good.
Central limit theorem, baby. Just all washes out.
I think it would be. And since it can spin in place, doing that kind of thing, that's it's that whole woulda, shoulda, and that kind of thing. I would just focus on other things and not focus on what I'm supposed to. Not
Right.
focus on that like I could have. That's just. I'll not make that mistake again. Because that was fun. It was really, really fun Saturday. I had a great time, and everybody had a good old time, and we had great social interaction, if you want to call it that way, and it was really good. I really enjoyed that.
Well, appreciate
and so
you
far,
taking-
nobody came down with COVID yet. So
far. Oh, and as far as my thought, Ray, on how to beat Scott in the can, I'm thinking it's going to come down to horsepower. And what I mean by horsepower, I'm not talking about. It's going to be a combination of up in the speed game that you have on the motors and the CPU, the processing power and image recognition stuff on the thing. I think that's what's going to beat him on this thing. I don't think you're going. Shooting cans across the screen thing and stuff and all that, I think is wonderful. But the reality of it is, there's a bunch of randomness, like Carl says, that grabbing the thing and just actually being faster at grabbing and faster at acquisition on the thing, I think is what's going to beat him on that deal. Especially if he doesn't know it's coming. He's not on this, is he? Okay, he's not on this one. So.
but shooting cans sounds like a lot of fun.
It does sound like a lot of fun.
There are style and fun points together. So.
Yeah. But I think that I think his time was 1 minute and 50 seconds. That's really good.
Yeah,
that's really good.
Yep.
Yeah, he's moving along. So I do agree with you, Harold. That's still beatable. I mean, because his robot, if one's willing to sacrifice smoothness, they could probably get going a lot faster. Because his robots weren't what I'd call unbelievably fast.
No, it's not.
That's what I'm thinking.
I would say there's no wasted motion.
Mm-hmm.
And
smooth.
Yeah. So I mean, even considering probably the algorithm of picking up cans once you spot them might do you good too. So I think there's still room for improvement.
Yeah. My guess was, looking at that in the realistic thing, and this is me talking that I hadn't even done it yet, so maybe I'm talking out with some orifice, but I'm thinking you could get that down to 60 seconds. If I make guess. I think that's a realistic thing. If you say
Harold the
anything
Gauntlet.
like that, I don't know if you can do that. So
10 seconds a can.
yeah,
Ooh,
Pretty
that'd be
fast.
pretty fast.
that would be pretty fast.
Yeah.
Agreed.
Yeah, actually on that platform, the motors are just about maxed out as far as speed, and it is not a smooth, control algorithm. It's about as jerky as you can get. So, to get the responsiveness up, and yeah, it's just that it doesn't, it doesn't behave consistently. It's like
Yeah. No, I understand that. I'm just looking at a goal that if I ever compete, I would like to. I think that's a lofty goal to get there because I don't mind giving up a little beauty for some speed. It's there's a cat on YouTube called Cletus McFarland. I don't know if any of you guys know who they are, but he likes to put big engines in little things. And so I'm not a big fan of him. My friend a long time is, and he was showing me this. They got a Corvette, no shell, no nothing on it, put a big enough engine in to run like a sub however many second quarter. I'm like, so you're telling me aerodynamics at that range at a drag strip just doesn't matter? Nope, we just put enough horses at it, and who cares what it looks like? That's how they went on that deal. So, just throw enough horsepower in one way or another. I think is.
Well,
But I don't know what that means. I don't want that. I got some ideas, but I don't know what that means at the moment. So
I think that's an interesting goal, Harold, of a minute. I would have said a minute and 30 seconds would be easily done.
that's probably more
But
realistic.
a minute, that'd be cool. I mean, that's a nice challenge.
Can you, is it legal to grab 2 cans and take them?
No.
Yeah, they made a rule about that, Michael. Anybody want to tell them why they made a rule about that?
the leaf
No.
blower.
Well, no, it wasn't the leaf blower. We had guys that would have, think of it like a TIE fighter. Not TIE fighter. What is the one? Well, one of those ones that from Star Wars where the
X-Wing.
wings fall out to the side, and then
and
just
scoops them all up.
scrape all 30, across the whole field. And I actually saw 2 robots in 2 different competitions do that. So it gets kind of old after a while. Like I say, this is a good one because he's got a good solid timing, and but like I say, there's probably room there if you want to compete. You just because I don't think I want to say we were doing. I think it was maybe it was the one where you go out and come back, and he's maxed out on his speed on that base.
Yeah, and I was thinking.
So I mean, I don't think he can go much faster.
I was also thinking that if you could have when you have a moment, because I've got this computer vision thing that I've been playing with a little bit, and I've not even looked at it on how to deal with it. But if I can analyze all the ports that can, maybe do the min max on the travel. So that's so maybe you don't have to go as far because you've already located the cans all at once, and now you're picking them up all in optimal order, and figured out the order. And I would think that you could do that in less than a second. If you've got an image, maybe 2 seconds, and then get your pathing the way it should be. And now it turns into can I run the path and grab the can without crushing it us. I guess crushing the cans are against the rules. I guess.
No.
Yeah.
Nope.
Crush the can.
I'm going to eventually give that competition a shot.
Okay, we got 2 contenders now.
I got to build a robot first. I'm talking out my orifices here, but
Yeah.
I got to build a robot first. But I think that'd be my approach: was how can I grab an image enough to locate all 6 cans and then path it? That would be and I might have just said a whole bunch of words that are really damn hard, and that's why no one else is doing it. I understand that.
Yep.
Well, I'm not sure since you got to run back and forth, order that you run them back and forth probably doesn't make a difference. You know what I'm saying? But what might make a difference, Harold, is the first can.
Yeah.
Otherwise, if you can highball like a lickety skit, grab the furthest can and push it in quick, and then come back, you might actually pick a few seconds off there.
Yeah. Yeah.
You have to
I don't
push and grab it. You
Or,
have to-
well, wait a minute. Maybe I'm wrong. Maybe it's the closest can to you because you're going to the opposite goal. So you do two things when you do that. You're taking the one that's closest to you in the first run to the other side, and you're also removing the furthest one that was if you were going after if you were going to go back for it. It's already, since you already pushed it in, you don't have to worry. So that's probably the one thing you can really do.
And
If you can,
and with that kind of idea, if you know your grabber has a firm grip on the can, you can certainly ramp up the revolutions on that motor.
you could just let it rip.
Let it rip. Yeah.
Yeah. But
I
then,
don't know if you ever saw Ron's robot. Ron had a little foot in the back that pushed the back of the robot up, and then his grippers would reach out and grab the can, and then the little foot would fall back. Well, it would go back up, so the platform would tilt up and basically lift the can off the ground, so you wouldn't have any interference with the can dragging on the ground. Which that duct tape is a little sticky.
You know, you lift up a 55-gallon drum with one of them. You tilt the drum and then slide under it. You can get your grippers to kind of tilt it and then scoop a plate under it, and then there you go.
Just give it a toss, huh?
having watched previous competitions, one of the things you have to be careful about when you're really going fast.
Yeah.
You really can't hit a can going fast. You have you have to come to a stop before you get to the can.
You'll just push it right over because
you'll shoot it 10 feet and it'll also fall over on its side. Now that would be a real interesting area of improvement. How could you grab a can on the fly, still going at speed, without it getting away from you? That would be, I don't think anybody's really solved that particular problem.
Ninja Flex, they think.
How about you have a pair of arms with a netting across it, and as you come up close of it, just lower it down on it, drag it all out, and then flop it back real fast, and that's where you're done, right? So you don't give it a chance to get away. You just
that might be a good idea, Harold. I did a gate. I'm sure you've seen that.
Yeah.
But I had situations where it's made so that if a can falls to the side, you can still roll it down with you. But I always ran into situations where, because of speed just a little bit off, the gate actually comes down on the can. Yeah, and that's a little funky. So anyway, but you're right. That would be a real interesting area of improvement because, like I say, right now, every solution I've seen, you pretty well need to be stopped when you actually get the can.
Yeah, I see that. I don't know.
So there's two improvements you could make. You could tune into your thing. Grab the nearest can on the initial run and figure out a way to be able to pick that can off while you're going full speed. That would really.
Yeah, I don't know what Scott does or what you do, Doug, but with the Pixie Cam, I just look for the biggest blob, and that's the closest can. So.
Yeah, as long as the can, you see, it also kind of depends where you enter if you got unlucky and somebody placed a can in the corner, okay, which that's legal and it's not and we in the past have almost always done that. The can in the corner often won't be seen in your field of view initially.
Oh yeah.
So, but anyway, that's all.
So, can placement is random,
It's supposed to be.
Huh?
Hmm?
Yeah, it's random on the day, but it's consistent for everybody running. They get the same
All right.
placement for
But I
everybody.
mean, it's random.
Yeah, we try to make it spread out as much as possible. Actually, I thought the can placement this year was a little easy, but that's okay. So,
Yeah, arbitrary might be a better
Well,
word
nobody
than
else
random.
volunteered to do it, so I.
no. I'm just saying is, they were all in the center 2/3 of the thing. Usually we put one in a corner, and you can't put them up against
By
the wall.
design,
We don't put
yes.
them up against the wall. I
How
think
close,
there's.
how
I want.
close to the corner do you have?
I want to say it's 6 inches, but you read the rules.
Oh,
And again, I mean, but it's, it is interesting. You guys came up with some ideas. So,
yeah, I'm gonna try to make a robot for the next time y'all do that.
Okay.
but if you get a minute and 50 seconds like Scott did, even if you came in second, you would definitely it would be very competitive.
I'd be the man.
Yeah. So if you can get any faster than that, you're really good.
I actually had a chuckle at Scott. Everybody else is like being all gingerly and stuff, and with the robots and getting out, and Scott goes, "Here, time to go," and just waters over the thing and just grabs in it, and just plops it down literally. It kind of made me chuckle a little bit. He's got that much confidence in what he's built and the fact that it's not going to mess up. That he just does
No
it.
lack of smack talk. That's for sure.
No lack of
That's what you need. Scott brings a lot of.
That's a part of the game, though, man. You gotta have smack.
He's also a very gracious competitor. He just tells Ray he sucks. That's all.
There you go. No, he tells me he's going to kick my ass. That's the,
Okay.
They didn't pull any punches.
I'm going to kick your ass.
Yeah.
Yep.
Well, cool. All right.
Yeah.
What else do we have? Oh, hey, Doug, there's one thing. I don't know. Did you see David Anderson's not here, but he had asked if when we post the results from the contest, we can include the distances that Harold measured for the spin mode things he and I did.
If they're available, I saw you sent Harold's sheet, so I can probably, if you tell me a number that you want because that goes in the Hall of Fame. That's where all the past results are. Yeah.
It looks like this. I added this to the sheet you got, but this was there's mine on top, and then that's his pirouette one, David.
Okay. All right. If I can figure it out, I'll put it in there.
That's what those numbers mean. So
Yeah.
I mean, these are.
What should I call it?
These are inches.
Special modes or?
You can call it pirouette or spin mode.
Okay.
Result.
All right.
Pirouette or spin mode. Yeah.
Okay. Sounds good.
Yeah.
Yeah. By the way, guys, the YouTube is posted. So you can go out to the channel and look at the YouTube video. If you see anything wrong with the grammar or spelling in the description, shoot me a note so I can fix it. But it's out there.
Very cool.
Cool.
Okay. Who is next?
Excavator going down I-75.
Somebody's audio is really breaking up right now.
Do you have any videos of excavator going down I-75?
Is that for stream?
Yeah, I think that's for Kareem.
Yeah.
I guess he's not there.
Not there. Oh well.
Yeah.
Working on the video right now.
Sorry, I was I stepped away for a minute. Something about an excavator going down the road?
Yeah. I guess we were asking if there any progress.
75.
Oh, I see. Okay. Yeah, actually, I was, did you just said that you sent out the results from Saturday or something
Oh,
like
the results aren't posted yet, but that will be in the Hall of Fame. I said the video is up.
Oh, okay. So what was the shortest distance on the four square or whatever it's called?
Inch and something.
Oh.
It's interesting. Pat actually, I think, had the closest, and his was 1 1/8 inches. And I think locally, I think it was about 1.5 inches by Scott.
1 5/8 by Scott.
Yeah.
2 1/4 by Doug.
Yeah.
And surprisingly, Hover Sim in normal mode did 4 inches.
All right, cool. Well, that beats my excavator because we did it on Saturday. I get that it doesn't quite fit the weight class guidelines, but we had about 6 inches with the excavator.
Whoa, that's
On
pretty
how
good.
big of a square?
It was only an 8-foot square.
Wow. All right.
Trying to keep it around the same as what you guys were doing.
Is there video?
There will be video. We're not going to share it until the full reveal is ready.
Cool.
So that'll be probably still a month out, something like that.
Well, there might need to be a revision to the weight class, huh?
Yeah. I think there's a dimensional requirement as well.
Yeah, I think it's 18 inches, but that's okay, Kareem. Anything you want to run like that, you just go ahead.
Yeah, you want to take it to Steve's house for Robo Columbus? We'll do outdoor foursquare at Steve's house.
Well, this is a rental, and it's like $4,000 a month. So probably, I got to turn it in on Friday. So we're kind of done with it.
Oh, commitment, man, commitment. Okay.
We'll see. Maybe I can get like a 2-day rental. Yeah.
Yeah, because Steve would surely appreciate like tracked vehicle foursquare marks on his property.
Yeah, I'm sure that would probably break the rules.
It definitely leaves marks. Yeah.
Yeah.
Doesn't have to worry about the obstacles so much, though.
Yeah, I can imagine.
It'd shoe it for Robo Columbus, wouldn't it?
What tree? What tree? Okay.
Very cool.
Well, I can show a motivational video for people to try to make the robots better.
Oh boy. Is it going to show it? I'll cover my eyes to start to get depressed. Oh yeah, that one.
So that's a robot that really has control. And I'm not going to make you watch the whole movie. I don't know how long it is.
There's some high order loops in that one.
But they have another video that I chose not to show because it shows a military robot and doing some kung fu against somebody. You don't want to get your robots that good.
All right. What else do we have for tonight, guys? Crickets. We got crickets. Summertime, longest day of the year.
The week after after competition. So I'm sure everybody put their robot up in the corner. I'm like, ooh, I don't want to touch that again. So now it's time to, in fact, I'm really amazed that Doug D went out there and did all of that work on his robot this week. But anyway, Robo Columbus.
There we
It's
go.
right around the corner. So
3 months.
now,
Great.
now time to go.
All right. Well, cool.
All right.
Well, on that note, guys, I'd move we call it a good evening and start dreaming about Robot Columbus. Make Doug happy and
Yep.
the results. And have a good night. Take care, guys.
So, Carl,
Yes, sir.
regard to